All right, so let's look at a couple more trigonometric equations. So one of these you can solve for x without doing any kind of factoring or anything like that. One of them you can't. Which one do you think you can just kind of like straight up try to solve for x? Kyle, you have an idea?
Would one just that cancel out? Because the CSC is the opposite of
Sine. I know what you're saying. I know what you're saying. It's a good idea, Kyle. No, the answer is no. So, which one of them, though, can we just solve for x? Not worry about factoring or anything with parabolas or anything like that. I see lots of x's on that first one. How many x's are on the second one?
Oh, only one.
Just one. So I think you can just peel stuff away from it one layer at a time, if you will, like an onion, and you can get x by itself. So what's the first thing we should probably do to get x by itself then?
Get rid of that 4.
Which one? There's lots of them.
The one on plus 4.
This one? Do what with it?
Subtract.
Subtracted. Okay, I'll show my work. I'm going to stop showing my work here in a second. All right, then you should divide by which 4?
Outside.
This one's outside. This one's locked inside. You can't touch it yet. So a lot of you on a problem like this, not surprisingly, will probably be tempted to try to divide that 4. But like I said, it's trapped inside of the cosine. You cannot get to it until you remove the cosine layer. And how do you remove cosine? Okay, inverse, great. So this is the kind of stuff I'm going to start putting on quizzes next week, not tomorrow. Do more practice first. Is inverse. Inverse cosine cancels cosine, so you get 4x is the inverse cosine of -1. So then basically you need to figure out what the inverse cosine of -1 is. Don't touch the 4 yet. The inverse cosine of -1, remember that means as soon as you see this, you should be thinking angle. What angle has a cosine of -1? You can do that different ways, see, because now you guys know graphs of cosine curves, and you know the unit circle. You use your preference. Some times it'll be easier to do one way versus the other way. Isn't cosine -1 in certain spots? At the bottom of the valleys? So you could think about it as a graph. I don't want to sketch a graph though, so my preference is I'll use unit circle this time. So cosine. Cosine is which coordinate? X or Y? X. Where's x -1? That's what this says. This says where is x -1 really? Here?
Other side.
Here? Here? Yes. Confirm. Some of you guys like to do your unit circle risky. I'd write it down just to make sure. And that is what angle? What angle's over there? 180 degrees. We're always in radians though. Unless the problem in the book says there's a couple that say 2 degrees. But
So it'd be pi.
it's pi. Very good. So this is pi. Perfect. So we've got 4x equals pi. Now not just pi would work. Any coterminal angle with pi would work. So you can put plus all the way around to that same spot. 2 pi, and any number of times around would also work. Okay? But this problem didn't ask you to find 4x, did it? It asked you to find x. So what's the very last step? Divide by 4. You're going to be tempted to try to do something with this 4 before the last step. I'm telling you, if there's stuff locked inside, you cannot touch it until the very, very end, okay? That's a mistake people make a lot. So what's the answer here then? We've got x is equal to 1/4 plus a half. Is that a half? Yeah, a half k. K, of course, being any integer. On your worksheet or your homework, if you just want to write k as any integer once at the top or something, that's fine. You don't have to keep writing it every time. All right. So there's one problem. This one I don't think you can just solve for x because there's lots of spots. Now, Kyle a second ago was talking about something might just cancel. I think he was trying to think like cosecant goes with sine.
Yeah.
If this had said sine times cosecant, that would cancel to 1.
Is that sine times? Okay, it's sine of x times cosine, right? Like the x is in a multiplication.
Yeah, it's multiplication. Yeah, this is like the secant times the cosecant. See, I'm not even saying x because I don't want to confuse the issue, Sean. Good question. All right. So if it's something like this, I think the first step is to subtract this guy to the other side. So that you'll have this. I'm setting it to 0 because I realize that I can't just solve for x. Hopefully it'll factor. Otherwise, I'm going to have to know more trig than we currently know. So I crafted your problems real carefully so that they didn't involve more advanced trig. Yeah. So, which factoring technique will help us here? Looking at the last number and combinations of it, standard trinomial, difference of squares, what they share, which one? Difference of squares, what they share, or looking at a last number combinations? Well, there is no last number. It's not difference of squares, I don't see squares. It's got to be what they share. What do they share? They share a cosecant of x. Don't they? Don't they both have it? So if I take it out of this one, if I divide it out of this one, what's left? Cosecant. If I divide it out of that one, what's left? The 2, or 2 times 1. Yeah. Now we've got it factored. The whole reason to factor, remember, is because you use that property of 0. It's real nice. That says if you've got a product, it's set to 0. If this is 0, it works. Or if this is 0, it works. Notice, I'm splitting this up with bullet points into 2 separate problems. I will expect to see on a quiz or test or whatever, you having these bullet points. Because it's telling me you realize there's 2 separate problems that you've got to solve then. Okay? So, where is cosecant of x equal to 0? Can you guys help me? You knew what to do over there very nicely. How do you get inside and get x? You use the inverse cosecant. I don't think we've worked with that very much, but okay. Cancel. So you get x here is the inverse cosecant of 0. I think when we did this last time, this was a little tricky. We don't have a button on our calculator, for instance, for cosecant inverse. So we've got to change it into sine, exactly. So this is the same thing as the sine inverse of what? Remember, they're related because they're reciprocals, right? Reciprocals. Yeah, so what happens when you do 0 and you flip it? It's weird. Ah, very nice. So Rachel's saying undefined. Let me try to show that to you. 0 is like 0 over 3 or 0 over 5. I can put whatever I want under here, right? What happens if you flip that and go 3 over 0? It's undefined. So this is the same thing as inverse sine being undefined. So there's all kinds of ways to think about this. Like I said, you can use graphs, you can use the unit circle. I think thinking graphs this time is a much better way to go. You can think graphically about this statement or this. They're the same thing. This says, where does the sine wave become undefined? Think about it. It's a wave. Is there any asymptote on it or anything? It's a wave. It's defined from negative infinity to positive infinity. That has no answer. This has no solution. Now, if you guys don't like that, think about this. Cosecant, what's it look like? It's lots of the little parabola guys, right? There's some up above starting at 1, and there's some down below facing down from negative 1. Are any of them ever 0? No. No. So either way, there's no way to do that. That's no solution. Okay? So graphs also matter. This guy, same thing. Let's set it to 0 and solve. So that says secant is 2. Inverse secant on both sides, and you'll get inverse secant of 2. I don't know how to do inverse secants very well, so I'm going to change that to inverse cosine of what? What's 2? If you flip it. And that should look familiar to you from the unit circle. Now you could of course do this with a graph. You could think about cosine or secant's graph and where they're equal to 1/2, but start trying to do that with a wave and you'll be like, I'm not really sure. So I think this is a triangle though that we know, yeah?
Is it 60 though?
Yeah, it's a 60, 30, 90. You've got it, Kyle, but let's be nice and specific. Don't think too hard. Don't burn that brain too much. This says adjacent. It's cosine, right? Adjacent, hypotenuse, triangle. Adjacent, hypotenuse. What goes here? We don't even need it, but that's the root 3. What we care about really is the angle, right? What angle? What angle is that? 60. That's what we care about. That's one of our answers. So one of our answers is x equals pi over 3 anytime we get there, so 2 pi k. There's one other triangle I can draw. I'll do the same thing. Where else can I make it be 1/2?
If you go over
This way?
x equals y, negative x equals.
So you want me to flip left or down? So you
I
don't.
was go across.
Yes. So Rachel's telling me go down. She's trying to tell me go here because then you'll still have 1 there, right? 2, this will be negative root 3, but who cares? It's got a cosine of 1/2. Cosine is x. X is positive here and here. So 60 degrees there. What's 60 degrees in that quadrant? You don't even have to write it out if you don't want to. I just care that you have. You could go negative pi over 3, so that's what Michael's answer is. Nice. Or instead of saying negative pi over 3, you could say
5/3.
3/3, 6/3, back one is 5/3 plus 2 pi k. I don't care if you put that or that, it's the same answer. But if you just had this, you're going to miss some points because you don't have those other answers, you know what I mean? You're not going to miss that many points because you're still doing pretty good. But, okay? At this level, anyway. Let's look at 2 more. All right, one more example. So can you guys see that trig is starting to come together a little bit now? I mean, the unit circle's coming up. We're doing factoring, which is not trig, I guess, but we're thinking about the graph sometimes. All this stuff gels together. It's all one. And so I like to think about it, if you've had my philosophy class, Sean's had half of it, but I like to think about this as Plato would have thought about mathematics. And that is, there's like some higher level form of trigonometry and equations, graphs, unit circle calculations. They're all trying to access that same one big unified truth. They're just different ways, different windows to look through. It's like a house, and you've got windows on this side of the house that see one part of an image. When you go to the bedroom, it looks a little bit different when you look out at the street. They're all just different ways to look at the same thing. So that's how I think about trigonometry, and I think you guys should start to feel that. Maybe. Maybe not yet. Anyway, so this guy's already factored, isn't it? Yeah. So I should... Two separate things, yeah. 4 sine squared minus 2 is 0, and if that's 0, the whole thing will be 0.
Aaron Lewis, please report to the administrative office.
If that's 0, the whole thing will be 0. So let's start with the smaller one. How do I get theta by itself?
Log inside the
What, Rachel? Yeah, it's locked inside of tangents. We're going to have to use an inverse tangent. But there's something else. There's another layer outside of it. Hey, I got to get rid of the squared. How do you get rid of squared? Squared. Okay. Humongous, terrible mistake, which doesn't matter on this problem, but yeah, I ought to do this, right? Now this time it didn't really matter, but it does most of the time, because the square root of 0 is 0, and plus or minus 0 is 0. Then we're going to do what Rachel's saying, unlock theta by tangenting both sides with the inverse. So we'll write it. Cancel, theta is the inverse tangent of 0. So now thinking about my big idea a second ago, the form of trigonometry, if you will. What will be better? Can we answer this question with a unit circle or with a graph? You can answer it both ways. Which one's easy?
unit circle.
Oh, so you guys like the unit circle? Okay. Most of us are better at that than graphs right now, so I understand. I'd go graphs. Were you going to say unit circle too, Kyle?
Yeah.
Yeah, it's because you're better at it, I would guess. Think about the graph of tangent. Where's it 0? In the middle, that's the answer. The answer is x equals, or theta equals, 0. Why? Because in your head you should have this picture of tangent. Ready for it? Boom. It's 0 at 0. Now where's the next place it's 0? That's half pi. I think this asymptote's at 3/2 pi. Where's the next 0? What's between half and 1.5? Pi. So this one is 0 plus pi k. And that should also make sense on another level, because what's the period of tangent?
Pi.
That's why this is pi. The period of sine and cosine, usually you're going to put not pi k, but 2 pi k. That's one of the reasons why. Okay? And that one that we started with, the video, you guys remember the one that was like cosine of 4x? The end answer we got on that one wasn't plus 2 pi k. It was plus 2 pi k over 4, because that's what you do to get the period of the graph. That's also the thing that comes out in the equations. So it's all one thing working together. All right, so here, you guys tell me what to do in this last little thing for today. I need theta. Plus 2, okay. Divide by 4. So 1/2, 2 over 4 is 1/2, right? Square root, all right, we'll do that in red. Okay, Kyle's got us honest, I like it. So that gets rid of the squared, whoops. Sine, oh, we've got 2 here, I'm gonna use bullets. Sine equals, square root of 1 is 1, square root of 2 is square root of 2. Plus or minus, 2 problems. Could also be negative square root of 2. All right? These are, I think, what do you guys think? Do we want to use a graph of sine, or do we want to use the unit circle? Think about the graph. Do you know where the graph easily is 1 over the root of 2? I don't know anyway how that relates to the graph at all. But I do recognize a triangle from my unit circle.
45.
Yeah, it's the 45 one. So Rachel's kind of already got the right answer. Let's make sure. Opposite hypotenuse. Opposite hypotenuse. The answer is indeed the 45-degree angle. What other quadrant's going to have a positive sign? This one, or this one? Sign is y.
Because it doesn't matter if the adjacent.
Doesn't matter if the adjacent. This is opposite. Opposite. Hypotenuse. Same. And then we're also, on this one, coincidentally, also going to look at where it's negative. So that's going to be these two, isn't it? So this is like 45 degrees in every quadrant. So for your answers, we've got some answers right here, 0 plus pi k. You could do these 4 separate triangles. It's going to be a lot of writing. Pi over 4 plus 2 pi k. What's this one? How many pi's over 4? 3 pi over 4 plus 2 pi k. 5 pi over 4 plus 2 pi k. 7 pi over 4 plus 2 pi k. Man, I don't want to write all that. So you can, totally. That'd be the right answer. I'd be thrilled, you know? Be smarter, though. Be lazy. That's what mathematicians are. So let's think about it. So we had pi over 4. We had 3 pi over 4. We had 5 pi over 4. And we had 7 pi over 4. Condense those down into less writing. Do you have an idea, Michael?
Yeah, plus 1.
If you go this plus a half, don't you get that? Plus a half. Plus a half. So the smartest way, instead of writing all of these plus 2 pi k, that's fine. If you're having trouble with this, by all means, do it that way. Is to go and say the other answers are theta equals pi over 4 plus, not 2 pi k, but half pi k, yes. That covers this one, this one, this one, this one. That's going to go here, bounce, 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 and count them all. Or if you weren't quite that clever, and sometimes there's no way to condense these, by the way, so don't think it's going to condense every time. But this is how you get really good at this. If you weren't that clever, you could have said, hey, what's the distance? Look at it visually, guys. What's the distance between this spot and this spot on those two triangles? If I drew it nicely, that should be how far? 180 or pi. So you could go pi over 4 plus pi k is this one. And instead of writing both of those, you could just write 1. And you could say these are also 180 apart. So you could go 3/4 plus pi, and you don't have to write these two then. So there's all kinds of little tricks like that that you can do. So I'd recommend exploring them. Thanks. Okay, I thought we'd look at one more, little bit more challenging example of a trig equation. So let's look at this one. I think it's obviously got squareds in it, so we're going to probably have to do something like factor it. So as soon as you realize that you probably need to factor a trig problem, you want to set it to 0. So let's subtract the 2. So now 2 cosine squared minus 3 cosine minus 2 set to 0. All right, so this guy is a tougher factoring procedure, right? So I'm just going to do that. I'm going to go a little bit quicker than usual. We've seen it several times in class now. The reason it's tougher is because of this 2 in front. So you can try to just guess and check the factors. You got to check them in that case. I'm going to go through the algorithm. So we multiply these. We look at factors of -4. They'll give us -3. I think it's -4 times 1. Rewrite the outsides. Rewrite the inside using our clever choice. -4 cosine plus 1 cosine. And then factor this by what they share twice. So what do the first two share? Well, they share 2 and a cosine. Cosine is left there. If I take 2 cosine out of this and divide it, in other words, I'll get -2 left. These guys don't really share anything, and they're kind of matching this already, so I'm just going to pull a 1 out. So I've got cosine theta -2. These match. That means I did the problem correctly. So cosine theta -2 is shared by this whole term and this whole term. So what's left of this whole term is 2 cosine. What's left of this term is just 1, and there we go. It's nice and factored. So now we're going to set each one equal to 0 and see what we get. So we'll have cosine -2. Oh, don't want to forget your variable. Cosine of theta -2 equals 0 with a bullet point. And also, what do we have? 2 cosine plus 1 equals 0. All right, so this guy I'm going to add 2. So I'll get cosine is 0. That says inverse cosine of 0 if I operate with inverse cosine on both sides. So where is the inverse oh, it's not 0. My bad. It's 2. 0 plus 2 is 2. So where is the inverse cosine 2? You might start trying to draw a triangle with 2 on the adjacent and 1 on the hypotenuse. That's weird. Think about the graph of cosine for a second, if you will. Cosine only gets how big? Regular cosine never gets too high. Its amplitude is 1. So down 1, up 1. It never gets up to 2. It never goes up and touches there. There's no solution for this one. If you put it in your calculator by chance,
Ben Kaysen, Tanner Houghton to Miss England's room.
your calculator's going to say error. All right, this guy, same kind of deal.
Chandler Reeves and Joe Stosick to Miss England's room.
Solve for theta. You'll get cosine of theta equals -1/2. Take the inverse on both sides. You'll get the inverse cosine of -1/2. And I think we've done this already today. Where's cosine -1/2? That's a triangle. Cosine is x. X is negative here. So that triangle, adjacent hypotenuse. Or this one with the adjacent as -1 and the hypotenuse is 2. You can put the root 3 out here if you like as soon as you recognize the triangle. Remember, the whole point of this is finding the angle. This says what angle does that? And the answer, of course, is 60 degrees in either quadrant. So our answers are theta equals 2/3 pi for that one plus 2 pi k. And for this one, 4/3 pi plus 2 pi k. Now you might be tempted, like we were in that last problem, to try to shorten this and condense these down to just one set of solutions. And I think that's good, but also a slight bit dangerous. In the case of this problem, there's no way. The distance between 2/3 and 4/3 is 1/2. Or excuse me, I'm wrong. The distance between 2/3 and 4/3 is 2/3. But if you go 4/3 plus another 2/3 with your k, you're going to get over here. And that triangle does not have a cosine of -1/2. It'd be positive 1/2. So these guys cannot be condensed, I don't think. Not in any simple way anyway. So we're just going to have to leave those two sets of answers the way they are. So definitely pursue trying to condense your infinite sets, but it's not going to happen every time. Thanks.